So at this point, we have some code that theoretically implements a cell simulation and does it using a priority queue. So we wrote this run simulation, which would basically model cells splitting. It has a priority queue. We add one element to start with, and then every time through this loop, we pull off one element and add two more. And that's the process of the cell splitting. Of course, we haven't been able to check at all whether or not this works. And this is a kind of a graphical. I guess we could put a main inside of this and test it, but the best way to see this is going to be graphically. So in order to do that, there's a few more things that we need to add. We said that we're going to run multiple simulations. We need to have some data that's going to store several of these buffers so that we can draw them. So how about we make a var called all splits, and that is going to be a sequence of mutable buffer of double, and it'll start off empty. Okay. I need to have a private method that will run all the simulations and set that. So how about we make a private def run all sims. It doesn't return anything to us. All it's going to do is run the simulations, make them, and then call drawing.draw. So we need to set all splits equal to, well, I want a collection. I'm actually going to use a vector. Vector.fill. How many of them? Well, we have a variable called numSims. And we are going to call run simulation in here. So we need to make sure that when we first create one of these, this happens. Run all sims. I don't think I have to implement the 2xml unless I try to save this. I do need the properties panel to do something, but for right now I'm just going to make it return null. I think we've written our code so that if we get a null properties panel, nothing really happens. But we do have to implement draw, at least to a certain level, in order to make this work. One thing I want to put inside the draw is if all splits is empty, then I want to call run all sims. Now you might say, well, that couldn't happen because we run it here to start with, and that would set it to a value. Except we are potentially saving these things off. And you should recall that when we use default serialization, things could come back null. In fact, the thing is, I don't really want to save all of these here, so I'm actually going to label it transient. But when I label it transient, then I run into this problem that I have to potentially check whether or not those things are there. So if all splits is null, then I need to run all sims. Okay, what about drawing these things? Well, I want to draw some basically black lines for this. So I will set the stroke to be black. And I want to run through and scale all of my splits. So let's run through all my splits. So we'll have S in all splits. Okay. And then inside of here, I want to run through each one of these. So for I in S dot indices. And I'm doing that because, as opposed to running just through the contents of S, because the index is equal to the height. Okay, the index is the population, so my y value is determined by this I value, whereas the x value is determined by S sub I. So I need both of those. Okay, so we can calculate an x and a y. Now, I was just saying that in some ways the x is equal to the S sub I and the y is equal to I, except that we want to scale these so that they go from 0 to width and from 0 to height, and these values don't do that. So we need to put in some type of a linear transformation here. The S value needs to be multiplied by the width, but then divided by whatever the longest time is. And we don't have one of those. Maybe we should calculate one of those when we start. So max time would be going through all of the splits and mapping them to their last value, and then finding the maximum of that. Okay, that is the largest time value that we have. And so this will basically scale if at time 0 we get 0, and when the time is equal to the largest time, we get width. Okay, so that gives us the x value that we want. What about the y value? Well, the y value needs to go from we could go from 0 up to the height value, but we actually want to flip that, because remember, graphics coordinates go from the top down and most plots go from bottom up. So I am going to take height minus, and then instead of using I here, I am going to do I plus 1, because I actually want to draw a little line connecting things, times the height divided by the maximum population variable that we created. Okay, so I want to take and draw a line that goes from the previous point we had. So I want to stroke a line from our previous point, maybe that would be the last x and the last y, to our current x and our current y. The only problem there is I don't have a last x and a last y. And of course, after I've done this, then the last x would be equal to x, and the last y would be equal to y. All we have left to do is introduce those two things we're assigning to them, so they have to be vars. So let's put them right here. Var last x, last y, and the x value always starts at 0, and the y value is just going to start at the height, because when for a value of 0 here, we'd get height minus 0 times something, and so we'd just get height. Okay, so now we have code that draws. We can't quite test off of this yet. We still need to be able to add it into our drawing program, and it might be nice to have some properties. So we'll come back in the next video and we'll add that functionality, test this out, and make sure that it's doing what we want.